Today we're going to look at how to factor trinomials, and they are all of the form y equals ax squared plus bx plus c. And there are many different ways to factor trinomials. We have what's called the slip and slide method, California method, which is what I'm going to be showing you, grouping method, I might show you that one as well. And there are a few other ones, but I primarily just concentrate on what's called the California method and then factoring by grouping. And no matter, there's also an Xbox method. No matter how you factor though, you always start off the same way. The factoring methods are just different ways to organize the information you have to come up with your solution. All right, so the first thing we need to do is, these are not equations, I just have the trinomials, but if these were going to be equations, they would be equal to 0, or we would need to set them equal to 0, meaning I need every single term on one side of my equation. I also typically like to have my leading coefficient, which is that a value, that 3 right there, it's the one with the squared, if it's in standard form, to be positive, okay? So here's the two questions we ask ourselves. First question is, what two numbers added together will give you my middle coefficient? So my -2. Let me try to match this up here. Okay. And the other question we ask ourselves this simultaneously is, what same two numbers can I multiply together to give me the product of the first and the last terms? So 3 times -5 is -15. Okay, so we have to multiply those two together. And then we simply list factors of 15. Well, factors of 15 are 1 and 15. 2 is not evenly divisible. 3 and 5. And that's the only factors that 15 has. So we say, okay, 3 and 5, 1 and 15. Is there any combination of those two that could somehow give me a -2? And the answer is yes. If I use 3 and 5, the difference between them is +2. But if I make my 5 a negative, 3 plus a -5, where 3 minus 5 is -2, and 3 times a -5 is -15. So we found our two numbers. All right, so this is where that step right there is the same no matter how you're organizing it, no matter what method you use. The California method to organizing this is say, okay, I'm going to take my first term, and then I'll show you a slight shortcut to this, and I'm going to make two fractions with my numerator being that squared term. The bottom values are going to come from the numbers we just found, and we're going to put a p with them. All right, and then this is where every single time this happens, my squared and my letter down here will always cancel. So really, I typically just start here. 3p over 3, I take my first term with just the variable, not the squared. Whoops, got a little ahead of myself. Sorry, my second term goes there. And then you look at these fractions and just reduce them. 3p divided by 3, well, that just gives me p over 1, and yes, I'm leaving it over 1. 3p divided by -5, I cannot reduce that at all. So from here, we're going to go straight to our answer. Since this is p over -1, or over +1, that becomes p plus 1 in parentheses. And 3p divided by 5 becomes 3p minus 5. And that's our answer. That is our factored expression. So really, this whole factoring process is just the opposite of FOILing. Because if I wanted to check this, I would have to FOIL this. You remember, first, outside, inside, last? I'm going to do another one with you. And then I'll do one to show you how to factor by grouping. All right, so what two numbers added together give me my middle term? What same two numbers when multiplied give me the product of the first number and the last number, so -18. So factors are 1 and 18, 2 and 9, 3 and 6, 4 does not go into 18, 5 does not go into 18, and we are back to 6. So my values are 3 and 6. But in this case, my 3 needs to be negative because 6 minus 3 is 3. 6 times negative 3 is negative 18. So I'm going to do my 2n in the numerator and use these factors. So negative 3, positive 6. My first one does not cancel or reduce, but my second one does reduce to n over 3. So now this is 2n minus 3 times n plus 3. And the order in which you have these two things doesn't matter. Like I could have n plus 3 times 2n minus 3. Okay, they're both the same thing. All right, we're going to do one more. We're going to do factor by grouping. Okay, again, we started off the same way. And you guys actually might be a little bit used to factor by grouping. All right, I have to multiply these two again, so that's 12. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. So 2 and 6 is my combination. In this case, they're both negative. So now when we factor by grouping, it's like, okay, asking yourself, when I FOIL, I combine two like terms to get that. So that negative 8 was really a negative 2n and a minus 6n. And then we just bring down our first term and our last term. Okay, then we're going to insert parentheses. Now, one thing here is there always has to be a plus sign between your parentheses right now. So that negative with the 6, it needs to stay with the 6. Can't go in the middle. So then we look at each of these like little factoring problems. Say, okay, 3n squared minus 2n, what is their greatest common factor? Which you guys, I'm sure, have factored things like this before. But the only thing they have in common is an n. So I have 3n minus 2. Here, when that first term is negative, you want to factor out that negative. Okay? But I can't leave it in the middle up here because that's going to change the sign of my 4. The only other value they have in common is a 2, so I'm going to factor out a negative 2. So remember, when we factor, it's like dividing. So negative 6 divided by negative 2, that gives me a 3n. 4 divided by negative 2 gives me a negative 2. Now this is where you can check your work. Look, 3n minus 2 in parentheses, 3n minus 2. You don't purposefully just write down that they're the same, but you need them to be the same. And if they are, you're doing this right. So we're going to write down that factor that is the same, so my 3n minus 2, and then look at what I'm left with, n minus 2. And there's your factored expression. Okay, so 2 different ways to do the same problem. All right, so you guys have this worksheet to practice, and I did leave the answers for you. That way you have something to double check your work.